So we just figured out from your table and your graph that the pattern in 1.3 is what's called the geometric sequence. So it would probably be a good idea to write down a definition of what a geometric sequence is. We just had this up on the board. An arithmetic sequence adds or subtracts the same amount each time. What does a geometric sequence do? Multiplies by the same amount each time. So geometric sequence multiplies by a consistent amount to get from one number, one output to the next. By a consistent amount. And I'm going to add something in the definition here that goes with it. It's actually another vocab word. And this is going back to arithmetic before I finish writing this out. In an arithmetic sequence, that amount we were adding each time, what was that called? Common difference, right. So in a geometric sequence, now we're not adding, we're multiplying. But that amount we're multiplying by, kind of like in an arithmetic sequence, it also gets a special name. So the amount that we're multiplying by, that consistent amount, it's called a common ratio. So you have a common difference in an arithmetic sequence, and you have a common ratio in a geometric sequence. And that's why I paused here so that we could use that word in here to get that word into your notebook. So a geometric sequence multiplies by a consistent amount called the common ratio. To get from one output to the next. I'm going to steal, oh, well, we're going to put a couple of things. So first of all, the graph's not linear, right? It's curved. So that would be worth noting. And we're going to get more into that graph and the details of it as we go. But for now, just know that geometric sequences do not give linear graphs. So that's a feature of a geometric sequence, is that the graph is not linear. So we would call it a not linear graph, we call nonlinear. It's nonlinear. Graph is nonlinear. I'm just going to put a rough sketch of it in here. So the graph of it had this upward hook to it, right? So a geometric sequence is going to have a graph that looks like that. And the table I'm going to copy in here, and we're actually going to put the table in here a couple of times. Once to talk a little bit about this common ratio, and then we're going to put the table in here one more time to help you with the explicit equation, which is the last part of the problem that we hadn't done yet. And the explicit equation can be a little tricky because it's not linear. It's not something you guys are used to seeing. So I want to put something in your notebook in just a minute that will help you and give you some hints to see if you can see what the explicit equation is going to be. Question? It can be. So it multiplies by a consistent amount, but let's say if you multiply by 1/2. You can multiply by 1/2 each time, but that's going to chop it in half, right? Be kind of like dividing. So it could look like this. You could also get a graph that looks like this if it's getting smaller. But both of those, you notice they have that curved shape to them. They're definitely not linear. So that's the way you can spot that geometric sequence. That was a good question because we haven't seen one that goes down yet. But that's kind of a preview of what it looks like. In the table, like I said, we're going to copy part of the table here just so I can show you a little bit more about that common ratio since we're in your notes right now. Here's just the first little part of the table that you guys all did on your homework. So you all have this in your table. We're just copying down the first teeny little bit of it. So we know that we're multiplying by 3 each time, right? That's our common ratio.
Yeah. If you multiply by 3, then you turn the 6 upside down.
Okay. In our arithmetic sequences, we said it was called a common difference because you could actually go backwards and subtract to figure out what that number is. This is kind of the same idea. It's called a common ratio because if I were to divide these numbers, what's 12 divided by 2? Not 3. 12 divided by 6 is... And if I go backwards again, 6 divided by 3 is... So if you're having a hard time seeing what that amount you're multiplying by is, you can divide the outputs and see if they do the same thing each time. And you notice that that is a ratio, right? That's where the common ratio name comes from.